Okay, we're going to look at a new topic from Chapter 9 in Section 1, and that is cube roots. This feels exactly like square roots. You undo square roots with the square, you undo cube roots with the cube. There are some new ideas here, though, so we're going to work through that. So we're looking at page 232, that first cube root question. And the first thing we're going to do is exactly what you'd expect. We're going to undo the cube root by taking the cube of both sides. Now the left side is easy. The problem's over there on the right side. On the right side, we're cubing a sum. And when you do that, you actually have to multiply that x plus 2 by itself 3 times. The left side's easy. The cube undoes the cube root. So we take the right side off to the side and we start to do some work. So there's those 3 factors of x plus 2, and we're going to take them 2 at a time, left to right, and just FOIL that. So when we FOIL it, we get x squared plus 2x plus another 2x plus 4. That's first, outer, inner, last. We combine the like terms. That's the 2 of the 2x terms. That gives us 4x. Now we have to multiply that by x plus 2, that third factor of x plus 2. I use the multiplication algorithm for that, just like you probably saw in Math 100. And then I multiply first the 2 into everything, so that first row is 2 times x squared, 2 times 4x, 2 times 4, and then I multiply x into everything, so that second row is 2 times x squared, 2 times 4, x times x squared, x times 4x, and x times 4. Multiplication is repeated addition, so now we add it up. Remember, we've squared both sides, so on the left side over there, we've cubed both sides, so on the left side, the cube undid the cube root, and we're left with the stuff inside, the radicand, 21x plus 62. Now, this is a cubic equation. That means that it has 4 terms. This one can have as many as 4 terms. This one has 4 terms. We're going to factor this by grouping. We're going to use the zero factor property. So the next thing that we're going to do is try to get a 0. That means subtracting the 21x and subtracting the 62. So there's our 0. Now this has got 4 terms, so cubic or not. We're going to try to factor it by grouping. So to that first pair, we pull an x squared. We see that an x plus 6 is left behind. And then we see that for an x plus 6 to be left behind in the second pair, we have to factor out a negative 9. Quickly check that negative 9 times positive 6 is negative 54, and you're in good shape. So now we can factor out the x plus 6. Of course, left behind is x squared minus 9. This will give us our first solution, and our first solution is x equals negative 6. That x squared minus 9, you could factor it further, but I'm going to use the square root property. I'm going to say that x squared equals 9. That's going to give me 2 solutions, positive 3 and negative 3. And all 3 of these work. And the reason that all 3 of these work is that you're taking cube roots. And you can take the cube root of a negative. So there's our first look at that first example. Okay, our second example of a cube root question. This has a little work to do at the beginning, getting the cube root by itself. A cube only undoes a cube root. It does not undo subtraction. So if I tried cubing the right side, I'd be trying to use the cube to undo subtraction. And of course, the cube doesn't undo subtraction. Addition undoes subtraction. So the first thing that we have to do is we have to get that cube root by itself on the right side. And there's an x over there. That x is attached to the radical with subtraction, but the x itself is positive. So to get rid of it, we have to subtract an x from both sides. That's going to give us an awful lot of negatives. So we've already got a negative 7 on the left side. Now we've got a opposite of x over there as well. And then, of course, that cube root is negative. So before we do anything, let's multiply through by a negative 1. Let's just change all the signs. You can also say that as dividing through by a negative 1, just to undo all that subtraction. So now we've got a much nicer question, similar to the previous example. And of course, what we're going to do next is cube both sides. When we cube the left side, we're cubing a cube root. That's going to undo that cube root and leave us with the stuff inside, the 172x plus 868. On the right side, we're cubing a sum, so we have to take that x plus 7 cubed off to the side and do what we did before. That is, multiply by itself 3 times. So when we multiply the first pair, we're going to get that trinomial, x squared plus 14x plus 49. You can FOIL that. I've shown those steps there as well. Then we're going to multiply by that third factor of x plus 7. I'm going to use the multiplication algorithm to do that. So there's the 7 being multiplied into everything in the first row. 7x squared. 7 times 14 is 98. And 7 times 49 is 343. And in the second row, there's x being multiplied into everything. X times x squared is x cubed. X times 14x is 14x squared. And x times 49 is 49x. Multiplication is repeated addition. We're going to add these up, and that gives us the 4 terms. Now we still have the left side, so we can't use the zero factor property yet. So let's get rid of it. Let's subtract 172x, and let's subtract 868 from both sides. Now I've got a 4-termed polynomial, so we're going to try to factor it by grouping. Out of the first pair comes an x squared, and that 21 is left behind. So we're going to see if we can factor out a negative 25 to leave x plus 21 behind in the second pair. So get out a calculator and check that negative 25 times positive 21 is in fact 525 negative. Now we're going to factor out the common factor of x plus 21. That leaves an x squared minus 25 behind. The x plus 21 gives us a solution of negative 21. That factor is negative when x is negative, or that factor is 0 when x is negative 21. Then I'm going to use the square root property on the second factor, setting it equal to 0 and then adding 25 to both sides. And then when we take the square root, we get the positive 5 and we get the negative 5. And for the same reasons as the previous example, all 3 of these work. And that's because we're taking the cube root, and you can take the cube root of a negative. It keeps the sign. So check that all 3 of those work on your calculator, and you'll have all 3 solutions to this cube root equation.